Math 83, Unit 2, Lesson 6. We're going to solve a system of linear equations by substitution. Now we solved systems in Lesson 5, and we saw that when we graphed the two lines on the same coordinate graph, we could either have two lines that crossed, and the solution was the point where they crossed, or we had lines that were parallel. The lines would never cross, therefore there was no point that they shared, so we said that there was no solution. And then the third type of answer we could have is if the two lines were lying right on top of each other and they coincide. We said that we had an infinite number of solutions because every single point on the line was a solution to both equations. So in number 1, we're going to have an answer either that's going to be a point, or it's going to be no solution, or infinite number of solutions. And we do that by substituting. If we can see in the second equation that x is equal to 3, we're going to go ahead and substitute 3 in place of x in the first equation right here, and then solve. So we have 2 times, and then we're going to go ahead and substitute that 3 in place of x. And then we have plus 3y is equal to 12. If we continue to solve for y, we do 2 times 3 is 6. And then we want to subtract 6 from both sides, and we get 3y is equal to 6. And then we want to divide both sides by 3, and we get y is equal to 2. Therefore, this system has a solution of x being 3 and y is 2. And if I wanted to go back and graph these two lines, I would see that they would cross at that point of 3, 2. Looking at number 2, we have two equations, and we're looking for the one that has either the x alone or the y alone to start. Well, I can see y is alone in the second equation. Y equals x plus 4. So I can take y plus 4 and I can substitute that in place of y in the first equation. And I can rewrite this as x plus, and instead of y, we're going to put in an x plus 4 in parentheses in its place. And that's all going to equal 8. Now there's no number in front of the parentheses, there's just the number 1. So I can go ahead and drop the parentheses at this point. And then I need to combine like terms on the left-hand side. So x plus x is 2x, plus 4 equals 8. Then I'm going to subtract 4 from both sides and get 2x is equal to 4, and then divide by 2. So x is going to equal 2. Now to finish this up, I know that the answer for x is 2, but I need to go back and find y. So I can take this x equals 2 and substitute it back in the second equation and get y is equal to 2 plus 4, which makes y equal to 6. And now I can put those two together as an ordered pair of 2, 6. This is the point where those two lines would cross if we had graphed them. Therefore, the solution is 2, 6. In number 3, we have y equals negative 3x minus 15 and y equals negative x minus 9. Both of them have been solved for y. Therefore, I can just go ahead and plug in this negative x minus 9 in place of y here in the first equation and set the two equations equal to one another. So we have a negative x minus 9 that's getting plugged in for y, and that's going to equal a negative 3x minus 15. And now I just have to solve for y. To do that, I have to get the x's together on the same side of the equation. I can do that by adding 3x to both sides. And it's gone over here, and a negative x plus 3x is going to be a 2x. Minus 9 is going to equal negative 15. Then we're going to add 9 to both sides, and we get 2x is equal to negative 6, and then divide by 2, and then x is going to equal a negative 3. So we have found the x coordinate of the point that's the solution, but we have to now go back and find the y value. We do that by plugging -3 in place of x, either in the first equation or the second equation. It doesn't matter which one. So we'll go ahead and put it in the first equation. Y equals -3, and then plug in a -3 for x, minus 15. -3 times -3 is a positive 9, and then 9 minus 15 is going to be -6. So our y is -6. We can plug that in here, and our solution is -3, -6. That's the point where those two lines would cross if we had graphed them, and it's the solution to our system. In number 4, we have y alone in the first equation, and we can go ahead and substitute a -4x plus 10 in place of y in the second equation. So when we rewrite this, we have 2x plus 3, and then we're going to substitute in a -4x plus 10 in place of y, and all of that's going to equal a -10. Now, to clean this up, we're going to go ahead and distribute the 3. 3 times -4x is minus 12x. 3 times 10 is 30. Combine like terms, so we have 2x minus 12x is -10x. And we're going to subtract 30 from both sides and get a -10x is -40, and then divide both sides by -10. So x is going to be 4. So now we have the x coordinate of the point where these two lines are going to cross, but we have to go back and find the y. So we substitute 4 in place of x, and we can do that in the first equation. We have y equals -4 times, plug in 4, plus 10, and we get -4 times 4 is -16, plus 10 is going to be a -6. So 4, -6 is our solution to this system. In number 5, our variable that's all alone is in the second equation. We have a y equals -2x plus 3. So we're going to substitute that in place of y in the second equation. And we can rewrite this as 4x plus 2. And in place of y, we're going to substitute a -2x plus 3. And that's all going to equal 2. Now when we distribute, we get 2 times -2x, that's a minus 4x. And then 2 times 3 is going to be a 6. And when I simplify on the left, a 4x minus 4x, now all my x's are gone, and all I'm left with is a 6 equal to 2. With no more variables there to solve for, and this being a false statement, this system does not have a solution. So we say that this system has no solution. If we were to graph those two lines on the same coordinate plane, we would see that they would be parallel lines. So let's take a look at number 6. Looking at the two equations, the one that has the variable that's all alone is this first equation, y equals -2x plus 1, so we're going to substitute that in place of y in the second equation. And we're going to rewrite this as 6x plus 3 and substitute in a -2x plus 1 in place of y, and that's all going to equal 3. When we distribute, we get 3 times -2x is going to be a minus 6x, 3 times 1 is going to be a 3, and then 6x minus 6x is 0, and so what we're left with is 3 equal to 3. Now this is a true statement. When all of our variables drop out and we have a true statement, this system is going to have an infinite number of solutions. If I were to get y alone in the second equation, I would see that both equations were exactly the same. They would both equal y equals -2x plus 1. They would be the exact same line. If I were to graph them on the same coordinate plane, they would coincide. Therefore, every point on the graph would have been a solution. In number 7, I'm looking for the variable that's all alone, and I can see in the second equation I have x alone, and x is going to equal y minus 9. So I'm going to substitute all that in place of x in the first equation. And I get 2 times, and I'm going to plug in y minus 9, and then I have plus 3y is equal to 7. So when we distribute, we get 2y minus 18 plus 3y is equal to 7. Combine like terms, 2y and 3y is 5y, minus 18 is equal to 7. We add 18 to both sides, and we get 5y is equal to 25. Divide by 5, and y is equal to 5. So we have now the y coordinate of the solution. So now I'm going to go ahead and take this y equals 5 and substitute it back in to the second equation. X equals, and instead of, we're plugging it right back in here, instead of y, I'm going to plug in a 5, and then 5 minus 9 is a negative 4. So negative 4, 5 is the solution to this system. In number 8, we don't have a variable that's alone. So we need to solve either for x or y in either the first equation or second equation, whichever one's easiest. And I can see in the second equation to get this x here by itself is the easiest one to get alone. So I'm going to take my x plus 2y equals negative 6, and I'm going to get that x alone by subtracting 2y from both sides, and I get x equal to negative 6 minus 2y. Now I'm ready to substitute negative 6 minus 2y in place of x in the first equation. I'm going to rewrite this as 4 times, and then we're going to plug in that negative 6 minus 2y, and then have plus 7y is equal to negative 19. Now we're ready to distribute. We have 4 times negative 6 is negative 24. And then we have 4 times negative 2y, that's a minus 8y, plus 7y is equal to negative 19. We get those y's together, so negative 8y plus 7y is a negative y. And then we're going to add 24 to both sides. And we get a negative y is going to equal 5. And then we have to divide both sides by negative 1 to get y alone. So 5 divided by negative 1 is negative 5. So now we have found our y coordinate of our solution. Now we need to go back and find our x. We're going to take negative 5 and we're going to substitute it back in. We can go ahead and put it back into this equation. That's the easiest one to do. And we have x equals a negative 6 minus 2 times negative 5. That's going to be a negative 6 plus 10, and negative 6 plus 10 is going to be 4. So our solution is 4, negative 5. Now we're going to solve word problems involving systems of linear equations. In number 9, a married couple had a combined annual income of $54,000. The wife made $6,000 more than her husband. What was each of their incomes? We can let x equal the husband's income, and then we can let y equal the wife's income. So if together they make $54,000, our first equation can be taking the husband's income plus the wife's income together, adding them together, and that's going to equal $54,000. Now we have to come up with a second equation, and we can do that with the second sentence. The wife made $6,000 more than her husband. Well, if the wife is y, and she made $6,000 more than her husband, we can take the husband's income and add $6,000 to it. And now we have our second equation. Now, to solve this system right here, we can take y equals x plus 6,000 and substitute that in place of y in the first equation. And we can get x plus, and in place of y, we're going to substitute in x plus 6,000. And that's going to equal $54,000. Well, I don't have any number here to distribute other than 1, so we can just drop the parentheses. And then we want to go ahead and combine like terms, so x plus x is 2x. Then we can go ahead and subtract 6,000 from both sides. And we get 2x is equal to 48,000. Divide by 2, and x is going to be 24,000. Therefore, the husband makes $24,000. Then we can go back and add 6,000 to that for the wife. So the husband is going to make $24,000, and the wife made 6,000 more than that, so the wife made 30,000. Number 10, Tom's Tree and Landscape Service charges $250 for a consultation fee plus $50 per hour for labor, and Lawn Perfect Landscape Service charges $370 for a consultation fee plus $20 per hour for labor. We want to write a system of equations to represent the cost of the two landscaping services. We're going to let H denote the number of hours of labor and C the cost of each landscaping service. So first let's look at Tom's tree service. Now Tom is going to charge $250 for a consultation fee plus $50 per hour. So the cost is going to equal $250 plus the $50 per hour, so 50 times H. Now the Lawn Perfect Landscape Service is going to charge $370 for consultation fee plus a $20 an hour for labor. So that's going to be $370 plus 20H. We want to determine the number of hours of landscaping that must be used for both services to have the same cost. Well, both of them are solved for the cost of C. So all we have to do is set each of those equal to one another and solve for H. So we can take our 250 plus 50H and make that equal to 370 plus 20H, since we want their cost to be the same, and solve for H. We have to go ahead and get our H's together on the same side, and we can do that by subtracting 20H from both sides. And we get 250 plus 30H is going to equal 370. Now we have to subtract 250 from both sides, and we get 30H is going to equal 120. Then we divide both sides by 30, and we get an H of 4. That means for 4 hours, both services would cost the same amount. So the number of hours of landscaping that must be used for both services to cost the same would be 4 hours.